Find the following antiderivatives. When you are looking at the antiderivative of t squared dt, what we will need to use here is the power rule for antiderivatives. The power rule states that if you are taking the antiderivative of x to the n power dx, this will give you x to the n plus 1 power. We'll add 1 to the exponent. And then out front, we'll multiply by the reciprocal of the new power. And to that, we add c. And this makes sense because we're trying to find the antiderivative, which is represented by this symbol here. And it is the inverse operation of what we do when we're trying to find a derivative. And when you use the power rule for a derivative, you subtract 1 from the power. So if we're finding an antiderivative, we need to do the opposite of that. That is, add 1 to the power. And then what you do is you multiply the front by the reciprocal of this new power. And then of course we have to add this plus c out here because there could be some sort of constant that we may not have known about that could have been there. And just very quickly, if you look at the derivative of this right side, that is, if you try to find d dx of 1 over n plus 1 times x to the n plus 1 power plus c, what this tells you, remember when you find a derivative using power rule, is that we will bring this exponent to the front, and what that gives you is an n plus 1 over n plus 1. Then you subtract 1 from this exponent, and plus 1 minus 1, well, the 1's will cancel. You'll be left with an x to the n power. And the derivative of c, a constant, is just 0. And what this really boils down to is that the n plus 1 cancels with the n plus 1, leaving you with x to the n power, which is what we started with when we are finding the antiderivative. So back to this exercise that we started with. The finding the antiderivative of t squared dt, if you take t and you add 1 to the power, and out front you divide by, or you take the reciprocal of that power, this is part of the antiderivative for this expression. The last thing we need to do is add that constant just to make sure that we have something being represented there. And these other two examples on the right, very quickly, are to illustrate something that I sort of glossed over in this last example. When you take the antiderivative of 12, this will give you 12. In here, you don't write it, but there is a variable to the second power, or to the 0 power. So if you add 1 to that power, we know that the variable will have a power 1. But what variable are you supposed to use here? It turns out, if you look at the differential that is lumped in with the antiderivative, we know that we need to use the variable p. So our answer here will be 12p to the first power plus c. Similarly, if you look at this example down here, you'll notice that x is the variable being used. So when we find the antiderivative for 3, really there's an x to the 0 power in here. And so we add 1 to that power. And then it turns out when you follow the rule over here like this, multiplying by the reciprocal of the new power, it turns out the reciprocal of 1 is just 1. so we don't need to do it from a constant. Oops. So this is 3x plus c. These are some basic antiderivatives.